Hello, and welcome to the section of the MATLAB tutor. In this section, we're going to learn how to solve simultaneous sets of equations, and we're going to do it symbolically. So we'll be using the symbolic math toolbox. So in order to do that, as we've discussed before, we need to go ahead and set some symbolic variables up. So we'll do a symbolic variable x, symbolic variable y, symbolic variable z, and we can see those pop up in the workspace. Now, the nice thing about working with Symbolic Math Toolbox is pretty much it's the same command as we used in the last section to solve a single equation. It's the solve command. So we open this guy up and we need to put our equations, our simultaneous set of equations in here in order to get MATLAB to solve it. So let's just say we have 3x minus y is equal to 2. So we'll close that off in a single quote on both sides. That's the first equation. Then we'll put a comma. Let's do x plus y is equal to 1. And we need to enclose that second equation in single quotes. So there we have the basic syntax of what we're doing. Now, you know, part of my job in teaching you MATLAB is to teach you how to do it, but to kind of point out the gotchas a little bit. So in the previous section, when we solved a single equation, we put the equation and then we did comma x or comma y to tell it what variable to solve for. Really, the best way to solve a system of equations is to go ahead and put it just like this, the equation, comma, and the second equation. But on the left-hand side here, let's go ahead and we'll do something like this. We'll open a bracket and we'll do x space y close bracket equals. What this is telling MATLAB to do is create a symbolic variables here. Here are the two expressions, the two equations that we have, and we're going to assign the results to a little tiny matrix here, x comma y. So what it's telling you to do is solve for x, solve for y, and put them in a little single row matrix like this. So when we hit enter, it'll go ahead and calculate the value for x, and it'll tell you it's 3/4, and the value for y, and it'll tell you that that's 1/4. So it solved the system of equations. Now let me show you what happens if you don't do that. You might get a little confused, and that's why I want to point it out. If you just type in what you would expect to work, you know, solve and then the two equations, and you hit enter, you get something a little bit unexpected. It's telling you that x is a symbol and y is a symbol. And you're like, okay, I know that. I know they're symbols, but what are the values? So you're a little bit confused. So the way you do it is you have to set the result of the solve function equal to some variables. And because you have two solutions, you need to put them inside of a matrix because of that. So then you get x is equal to this and y is equal to this. Now, let me, just for giggles, let me show you what happens. If I create, or I should say, if I set the results of this guy, okay, let me do it like this, solution. Notice I haven't defined a solution variable anywhere. If I take the solve algorithm for what I'm solving here and I dump it into some other variable, then what I'm going to get is it's going to tell me the result solution is equal to the following things: x, which is a symbol, and y, which is a symbol, because you know our two equations involve x and y's, which are sort of these generic algebraic symbols. So all MATLAB is really telling you is when you try to evaluate it and set it equal to a single name, MATLAB's saying, okay, I dump the answers in the term solution, which consist of x and y, which are both symbols. So the way to get at them, if you don't, again, this is if you're not doing it this way, if you're just dumping it into some variable, is you can access them as follows. Solution, notice solution is defined here, and it's a one-by-one structure. Solution contains x and y. So to get at the x value, you say solution.x, and it gives you a value. Solution.y gives you the other value. When I'm trying to sort of teach you by example how MATLAB works, if you take the solve algorithm, it's going to spit out two answers. One is x and one is y. Okay, but I'm taking those two answers and I'm dumping them into this single term, the single variable that I'm calling solution. So whenever I make this assignment, it puts the values of x and y in there, but it doesn't just display them. It's just telling you, look, the solutions are in there. In order to get at them, you need to do solution.x and solution.y. And this gets a little bit into sort of the programming language aspects. It puts it into a structure. That's why solution is labeled as a structure over here. And to get inside the contents of the structure, you put the name of the structure and then you put a period, and this is one of the variables that's inside of it, and then you put the name of the structure with a period and the other variable that's inside of it. So the bottom line here is there's two ways to solve a system of equations in MATLAB. The easier way, in my opinion, is to do it like this. You type solve both equations with all the variables in there, and you set the results equal to a matrix that contain x and y, which are the unknown values. In that case, MATLAB is going to just give you the values straight on the screen. That's kind of more in line with what a calculator would do. If you take and set the result of the solve algorithm to a single variable name, not a matrix, but just a single name, then it's going to dump the values into a structure that it creates. And in order to get at the values, then you'll have to access them like this. So those are the two ways to do it. I wanted to point that out because it is a little confusing and it behaves a little bit differently than you might initially expect. All right, so let's clear the screen and let's solve another set of equations. Now, that was the set of equations with a single answer for x and a single answer for y. That's something that you might do, on as part of a larger problem where you're trying to get numbers. But this is a symbolic math toolbox. It can calculate the solution to simultaneous equations even when you're not trying to get numbers, when you just have everything in terms of letters or in terms of variables or constants. So for instance, if I wanted to solve, let me just go ahead and tell you right now, I'm solving for x and y. So I'm going to put the results in this little matrix here, in this little row matrix. And what I'm solving is the following: 2 times x minus 3 times the constant c times y is equal to 5. That's the first equation. So I'm going to end the quotation there, comma, begin a new quotation. The second equation is c, which is again a constant, times x plus 2 times y is equal to 7. And I'm going to close this one off, and I'll close the parentheses off. What I have here, again, is two equations. The first is 2x minus 3cy is equal to 5. And then I have cx plus 2y is equal to 7. So if this just had numbers and x's and y's, then I would get numerical answers for x and y. But since I have a c running here, and c is not defined anywhere, then MATLAB is just going to treat c as just a generic constant. It's going to carry it through the manipulation of these expressions as if it were just another number that it doesn't know the value for. So your answers, in terms of what x and y should be, should have the constant c involved. Right? And let's see what happens here. We go ahead and calculate the value. It says x is equal to all this stuff for x, which notice involves the constant c, and also for y. So again, the answers that we got for x is this guy, and for y is this guy, and they all involve the constant c that was just generically thrown in there. So Symbolic Math Toolbox can solve these guys even when unknown constants are involved in the equations. And if you don't like really looking at the way this looks, you can say pretty x and pretty y, and these guys will be sort of a little bit prettified, a negative 5c minus 14 over 3c squared plus 4, and then you have the other one up here as well. So that is how you handle it. Basically, you put the two equations in there in the quotations, and you assign the answers to a matrix that contains x and y. Now, the way we just did that a second ago was just like this. Now, if we do the same thing again, and for instance, if we don't like doing that for whatever reason, we assign the answer to a single variable called Jason, then it's going to behave the same way. It's going to tell me, okay, the answer is Jason, but inside of there is an x and a y, which are both symbols. So to get at the answers, I can do jason.x and get the first answer, and jason.y and get the second answer. So either way you want to do it, either you assign the answer to a variable and then you pull the answers out using the structure definitions here that I'm showing you with the .x and the .y, or you just from the outset just assign the value to x and y inside of a little matrix like that, and you'll get the answers as well. All right, let's go ahead and close the section out with a final example. Let's go ahead and solve a nonlinear system. So far these have been pretty well behaved systems. But let's say we're doing x, y. We're solving for x and y. And the first equation is going to be 3x squared minus 2x plus y equals 7. That's the first one. And the second equation is x times y plus x is equal to 5, like this. And so you notice this is really not linear because you have 3x squared running around here, and then you have 2 times x times y, and then you have x times y here. So it is a valid system of equations. It's just not really linear because you have x times y running around everywhere. So it doesn't kind of fit the simplified form of a linear system of equations that we usually have. But since we've defined x and y to be symbols, MATLAB can pretty much solve anything that's solvable. And so I'll go ahead and grab the answers as follows. So x is going to be equal to this, and y is going to be equal to this. And what this is really telling you, notice we haven't really seen a solution quite like this. X has 3 elements, 5/3, and then we have this guy, and then we have this guy, and y has also 3 elements. What this is telling you is there's really multiple solutions for x and y. And the reason there's multiple solutions is because this is really a higher order, or sort of like a nonlinear system of equations. Usually when you have system of equations, the number of solutions you have is, you basically have one value of x, one value of y, one value of z, and so forth. But because we have x's and y's all cross-multiplied together here, we're going to have one pair of answers would be 5/3 for x and 2 for y. Another pair of answers would be this value and this value for y. And another pair of answers would be this for x and this for y. So there's more complicated sets of answers because this is a more complicated system of equations than you typically run into. But the bottom line is for you to remember, when you're dealing with the symbolic math toolbox, it's very powerful because you can pretty much put any equations you want to in here, and MATLAB will try to keep them exact, which is what it's done here. So again, if you want to see what the values of x are in terms of decimals, just take the value of x and pass it in there, and those are the values. And then for y, those are the values there as well. So go ahead and put it into MATLAB, assign the values to x and y, and MATLAB can pretty much handle almost anything you throw at it. And if it's not able to handle it, then it's probably too complicated for you to have been able to solve by hand anyway.